Good day to you all. So here we have Excel using the bisection method to solve for the approximate roots for the equation. Given the intervals with roots obtained through the incremental search method. So to start, let us start with interval negative 1.5 to negative 1. So as we can see here we have the first iteration, wherein the values of xa and xc are the extreme ends for the interval, and xb as the midpoint of xa and xc. Then, we are to obtain ya and yb through directly substituting the values of xa and xb to the equation. Then, we are to obtain yb specifically for its sign to help us determine on what part of the interval to use, whether the left hand or the right hand part. So as you can see in these cells, I have embedded in them formulas to make life easier. Just drop down. So here are the formulas. So back to the first iteration. Let us first drop down the formula for each cell. So back to the first iteration. So as indicated in this column cell, that we have to use the left hand part of the interval for the next iteration. So input negative 1.5 here, negative 1.25 here. So in the same way, it has been indicated that we have to also use the left hand part of the interval for the next iteration. So we input negative 1.5 here and negative 1.375, and the process continues. So for this part, we use the right hand part of the interval. Now this is where the bisection method and process stops for the interval. And we now have the approximate root for the interval, which is the last value obtained for xc. Now the process stops as the tolerance value for the iteration reaches less than 0.01. Then, for the next few iterations, we do the same. This time I've pre-filled the cells in accordance with my calculations earlier. So as you can see here, using Excel to use the bisection method to solve for the approximate roots for the equation makes life easier, with the use of functions and formulas that can be embedded in each cell. Now here are the approximate roots for the equation for each interval.
Okay, today we're going to talk about bisection method. With a given function f of x is equal to 2x cubed minus 4x squared minus 13x minus 4. Intervals with roots is between negative 1.5 and 1, negative 0.5 and 0, negative 3 and 4. Tolerance level must be less than 1%. First thing we have to do is we have to make a formula using functions. I used here is, the function name I use is my function for f of x sub a. There, my function. Insert that with a formula given, and then next is f of x sub b. My name for the function is my function 2. so as to be consistent. And when you save, the function name must be the same as the file name so as to work. The next is the middle term, the one you need for x sub b. When x sub a plus x sub c divided by 2, the function name is I function, and then we make use of x sub a and x sub c. Onwards, we will now use negative 1.5 and negative 1 as our x sub a and x sub c. We first input the functions negative 1.5 for x sub a and negative 1 for x sub c. Now we make use of the formula. X sub b is equal to the formula we need to find the middle term. So we make use of I function, x sub a and x sub c. X sub a, x sub c. X sub a and x sub c will be inputted into the formula, which will make negative 1.25. And now we will find f sub x sub a. Okay. F of x sub a, and then we make use of the formula my function x sub a. My function x sub a will be inputted into the formula we made, and we will get negative 0.25. Okay. Now we move on to f of x sub b. We'll also make use of the formula and the value we computed for the middle term, which is negative 1.25, and f of x sub b, my function to x sub b. The value of x sub b will be inputted into the formula, which will result in 2.093. And then we will multiply the two signs f of x sub a and f of x sub b, which will give us negative. With that, we will, if it is negative, x sub a will remain the same, and we will make use of x sub b as our x sub c. To clear command window, simply type clc. Now we make use of iteration 2. X sub a equals negative 1.5 as is because of the negative sign. X sub c will now become negative 1.25 because of the negative sign in the previous iteration. Now we use the same formula x sub b to find the middle term. Now we have it. Okay. Input. And now we will find f of x sub a and f of x sub b. F of x sub a is the same as the first one, so we will just copy it. Now we will find f of x sub b, my function x b, 1.1133 there. And now the signs, we will multiply the signs, which will give us negative. The tolerance level must be less than 1% or 0.01, means that you have to minus x sub b with x sub c. So we have 0.125 negative 0.125 is not less than 0.01. So we have to continue. So moving forward, CLC, we make use of the sign again, which is negative. So we use XA as is, and we now use the previous XB for our XC. XC equals negative 1.375. Now we find XB using our formula. And then we have f of x still the same. We will find now f of x sub b, which is 0.4810. We will multiply the signs, which will leave us with negative. Find the tolerance, which is still not less than 1%, not less than 0.01. So we still need to continue. So moving to the next iteration, we still make use of XA as is because it is negative, and then we make use of the previous XB as our XC. 1.4375. We find XB. And then we find f of x and f of x sub b. F of x sub a and f of x sub b. F of x is still the same. F of x sub b will give us 0.1280. Multiply the signs, still leave us with negative, so we continue. Still negative, we use XA, negative 1.5 as our XA. And then for our XC, we use our previous X sub B, negative 1.4688. And find the middle term, which will give us negative 1.4844. We now find f of x sub a and f of x sub b. F of x sub b will give us negative 0.0582. And now we multiply the signs. We will get positive. Having a positive value means we need to make use now of our x sub b, and our x sub c will remain the same. But the tolerance level for the iteration 5 is still not less than 0.01, so we need to continue. So the last iteration is positive, so we need to make use of x sub b as our x sub a, as you can see, and our x sub c will remain the same. Okay, x sub a is now negative 1.4844. X sub c negative 1.4688. Finding the middle term will give us negative 1.4766. Now we can say, or we can see that it is close to the, or it's less than 0.01. So the approximate value will now be negative difference of x sub b minus x sub c. The root is approximately negative 1.4688. And then we make use of, we find the other roots using the other iteration between roots using the formulas there and there.